Hello there, welcome to the AS Maths Applied June 2023 paper. Here we're looking at question 3 from the mechanics section. A fixed point O lies on a straight line. Particle P lies along the same straight line such that at time t seconds, where t is greater than or equal to 0, after passing through O, the velocity of P is v meters per second, as modelled by this equation here. In part A, it asks us to verify that P comes to instantaneous rest when t equals 3. So something comes to rest when the velocity is 0, so we'll substitute in 3 and fingers crossed it equals 0. So 15 minus 3 squared minus 2 times 3, that would be 9 and 6. 15 minus 9 and 6 is 0. Lovely. Therefore, at rest. Part B, find the magnitude of the acceleration of P when t equals 3. So for acceleration, we take our velocity equation and we differentiate it. So differentiate to find acceleration. So a equals 15 differentiates to 0, minus t squared differentiates to minus 2t, and minus 2t differentiates to minus 2. Now we want to find the acceleration when t is 3, so we're going to substitute in t is 3. So it's going to become a equals minus 6 minus 2, so it's minus 8 meters per second squared. Find the total distance travelled by P in the interval from 0 to t, to 0 to 4. So first of all, we'll go back to our velocity equation. And this time, to find distance travelled or displacement, we integrate the equation. So S is going to equal 15t minus third t cubed minus t squared plus c. We know that it passes through O when t equals 0. A particle does a straight line. After it passes through 0, this is its velocity. Yep, so when t equals 0, S is 0. So we now know that the distance, the displacement formula is 15t minus a third t cubed minus t squared, and c is 0. Right, okay, so now what's happening with this particle? So it's travelling forwards, it comes to instantaneous rest when t is 3, and then it starts to come backwards, and it's at this point where t is 4. So what we're going to do is we're going to find the displacement from O at 3 seconds, and then we're going to bring it back to 4 seconds. So when t equals 3, first of all, S is going to equal 15 times 3 minus a third times 3 cubed minus 3 squared. Okay, so let's work this out on the calculator. So 15 times 3 minus a third times 27 minus 9, that's 27. Okay, so what that refers to in my diagram is that this part here is 27 to get to t equals 3. Let's now work out when t is 4. So we're going to substitute in 4 into the equation. So 15 times 4 minus a third times 4 cubed minus 4 squared, and to that we get 15 times, I'm just doing this on the calculator now, 15 times 4 minus a third of 64 minus 16 is 68 over 3. Let's leave it as 68 over 3 for now. Now 68 over 3 refers to this gap here of 68 over 3. So to work out the total distance actually travelled, let's think about it. What would be best to do? Let's double 27 to make it 54, and then take away this bit that we don't need. That will give us this extra part on that side there. So 2 times 27, take away our 68 over 3. 2 times 27 minus answer on the calculator gives us 94 over 3 meters. And if we were to round that to a decimal, 31.3 meters. That's the distance travelled by the particle P between 0 to 4. Lovely, and there we are. That's the answer to question 3, worth a total of 8 marks. Let's now move on to question 4.